Before we go through the practice problems, I just want to recap a couple of things. So this first section is just to review. We're studying projectiles. So a projectile is any object that's launched into the air. And the projectile's path is called the trajectory. For projectiles that are launched horizontally, they follow this type of path. So this is a horizontal launch. If a projectile is launched at an angle, it makes a large parabola. We can represent the motion of a projectile by making something called a free body diagram. So if I represent my projectile as this circle, its path, we'll say that this is a horizontally launched projectile, so its path is going to follow this trajectory. And at each point along this trajectory, I'm going to put a circle. So I have one here, and one here. At all of these points, the horizontal velocity is the same. So all three of those arrows are the same length. For the vertical motion, as the object goes through its trajectory, it's accelerating because of gravity. So the arrow pointing downward, representing vertical motion, gets larger at each interval. So let's talk about motion in two directions. Just going to continue that here. So let's imagine that I have this magenta ball, and this magenta ball is being dropped, and as it drops at each interval, it's moving further and further. So that's the path of the ball dropped straight down. Now if we consider the green ball going in kind of a parabolic shape, let's say it has been launched horizontally. It's going to follow kind of this path. The interesting thing about the green ball compared to the magenta ball is that they both are going to be at the same spot at the same interval. So even though the green ball has been launched horizontally, it's gaining the same distance as the magenta ball. This is because as they fall, gravity is affecting them both. They have the same vertical motion due to acceleration from gravity. The horizontal motion of the green ball is independent of the vertical motion of gravity. So even though the green ball was launched horizontally this way, gravity affects it and accelerates it the same as it does something that is dropped straight down. So we call that the independence of motion in two directions. Another note on this is that unless there's some kind of contact force, the only force working on either of these is just gravity. A contact force would be like something pushing it or pulling it. So unless there is a contact force, only gravity is working here. So moving on, we'll cover vectors in 2-dimension. We have done this a little bit already. Now we're just getting slightly more in depth. So if this is the beginning, as the projectile is launched horizontally, the horizontal velocity, the velocity vectors stay the same because horizontal velocity is not changing. Gravity affects the object but does not affect the horizontal motion. So we call this direction the x direction. So this is the velocity in the x direction. And we can write acceleration in the x direction, but this acceleration is 0. On the other hand, for vertical motion, I'm drawing these arrows or these vectors getting larger the further I go. So this would be velocity in the y direction, and acceleration in the y direction is this way, and it's increasing. We don't really have a value, but if we know that this is in free fall on Earth, that would be negative 9.81 meters per second, with the negative sign just meaning that it's going down. So we see that vertical velocity is increasing because of acceleration due to gravity. It's basically the same concept from up here. Vertical velocity is increasing because of acceleration due to gravity. And if we were to combine the two vectors, we would get a parabolic trajectory. So from here, if we combine them, we would get a trajectory that goes this way, and at certain intervals, the horizontal velocity is always going to be the same. But as we move further through the path, the vertical velocity or vertical vector will get larger. So at this point, I'm going to end this set of notes and start a new video to go over the equations for 2-dimensional motion and also do a practice problem.